we'll give people a chance to see. So I don't know if anybody is watching this, and you're kind of like, what? Wasn't expecting any live hangout here. What's going on? Our good friend Sabin Iacob, who lives in Budapest, right? Or Bucharest? Bucharest, yeah. See how good friends we are. Has kindly gone through the trials and tribulations of hooking his telescope up to his webcam, and then he's broadcasting his webcam through into this Google Hangout. And we are just experimenting and testing out whether this is even functional and possible. So I don't know if anybody is even watching this. Probably people don't even know this is happening. But if anyone is like noticing that this is happening, can you post a comment or
thumbs up us or something?
Some way of knowing that there's human beings out there. And then we have more sort of tests and stuff we want to understand from your point of view. So,
hello. Hello.
So what's the telescope that you're using, Sabine?
A Skywatcher. It's 1000 millimeter, 15 centimeters mirror, so it's f6.6.
And so it's a reflector, right? Like a Newtonian.
Newtonian. And it's on an EQ3 mount, and it tracks in ascension, just a single axis.
But it has an electric tracking, so it's keeping the moon in the screen automatically.
Yeah, mostly.
Mostly, yeah. I can see it's got a little bit of a drift here. So Pamela, what are we seeing there on the screen right now?
Well, this is an area that's a transition between mare, which is black, basically. It's called basaltic rock, which is a fancy way of saying rock made by lava. Black basaltic rock, and the lighter features are lunar regolith. Lunar regolith is places where the lunar's normal crust material has been pulverized into a fine, sandy, gravel, nasty texture by the constant bombardment of micrometeorites. Now, in some places, you'll see craters that seem to be a lot lighter than the background surface, and those are craters that are newer. So just like your footprints on the beach may uncover darker, wetter sand underneath that will dry out and go back to the color of everything else over time, when things hit the moon, it reveals lighter dirt underneath, lighter soils underneath. And over time, those will, through processes of solar irradiation, go back to being darker like the surrounding materials as well.
And so we've actually got now a couple of people watching. We've got Andre and Rodolphe. So for you guys who are actually watching, and I'm going to try and talk to you while you've got the chats going on. So when I talk, do you see my window popping up onto the screen, and then that takes away the telescope window? Is that going on right now?
And I'm looking back and forth between two screens so I can read your comments and look at the moon.
Well, because on my interface in the Hangouts on Air, I can actually click on Sabine's feed and then be able to display what. So it's only showing like a regular Hangout. Like if you click on anyone's window in a Hangout, you'll see that screen just up on view at all times. But I'm trying to figure out, is there a way that I can force the view so that it only shows Sabine's view, or do we have to like have some kind of background hum going on Sabine's audio so that the camera will stay focused on his telescope, right?
We have a need for podcast-safe music.
Yeah, exactly. No, okay, so Clay says that you only see the moon, but I stay small. Now, Clay or any of the others, do does Pamela's window pop open when she talks? Like
Hi,
now?
I'm talking. Hello, hello, hello. Am I bigging or smalling? I hope the moon is imbigified.
I was able to click on my feed and just display the moon.
But that's because you're in the Hangout, Sabine. I mean,
Yeah.
now I've got you. Now I'm going to try taking off that click, and so now Pamela's shows up, and I don't actually see just the moon. So I don't know if that
Hi.
changed everything. Is that now? And then Sabine, if you talk, can you talk?
Boop. No, I don't seem to pop up.
Okay. And when I'm talking, do you see any effects? Sorry that we're asking you to be guinea pigs, but we're trying to figure out how to do this and do it right so that in the future we can have meaningful live star parties through Google Hangouts on air.
Yeah, I mean, the goal here is that we're going to hook up 3 or 4 telescopes in different parts of the world and have everybody join and be able to see the view, and then we could move from telescope to telescope and get all these cool live views and stuff. So that is the plan.
And we're hoping that Fraser can control what's going out through the Google Hangouts on air somehow just by clicking on pictures, and thus he can act as producer of the humans and producer of the video.
There's my daughter in the background. Okay. I saw that. Okay, so right now I have not got the camera locked onto people. So I do control. Okay, so I'm going to try that again. Oh, that's interesting to know. Okay, so I am going to now click it on the moon again. Where this is live, by the way, Phil. So before you begin a stream of expletives because you can't get your video working here.
But your timing is perfect because I'm about to have to take off, so I can trade one astronomer for another, and thus conservation of astronomers may be conserved.
Right. Okay, so now I've clicked the video again, so now only in my view, only Sabine's view is showing up, and so even though other people can talk, this is all.
And I'm going to talk by saying goodbye. I have to run. I'm sorry. Hopefully we'll do this more in the future.
You're real. I know. I threw this at everyone at the last minute, but I don't like to.
I run. Bye bye.
So I am here, and look, I'm ventriloquizing.
So this is Phil Plait, bad astronomer, everybody who is watching. So when it okay, good. Okay, so this is kind of neat, right? So then what this seems to be is that in my Hangouts window, when I click on a person's screen, that is the person. So what I'm going to do, Phil, you're going to be quiet, but I'm going to click on your window, and now everyone should see Phil's skeptical face up in the window, and that's because that's the one that I'm sharing. So can everyone just give me one last confirmation that that's what it's doing? Yeah. So sorry, I'm just looking at the chat. Someone asked some question. And we just get to stare at Phil for a second here.
But do you see anything in the chat? I don't see.
The chat is where people can watch the video live on the Google Plus page. There's so where that video is, there's comments that are underneath. And so John is saying that he doesn't see Phil at all, but someone else I think is saying yes.
I see you right now in my main window, but I'm actually one of the 3 people participating here, so it's hard to say. And I'm still fiddling with my camera here.
Right. So I'm wondering if maybe this isn't the behavior. Oops, I have a phone call. It's the school. All right. Hold on. Talk amongst yourselves. Yeah.
It's a lovely view of the moon. I hope that's what's in the main screen now.
Yep.
I believe, even though it's zoomed in pretty far, is that Mare Crisium at the upper right?
I can't zoom out, and I have no idea how the moon.
I think so. That would be, well, let's see, the moon is waxing gibbous right now. Now I can open up some software and take a look, and maybe I can identify some of those features.
Sorry, my son called and he said there was a really cool river flowing through his school park and wants me to come check it out. So we're gonna go do that afterwards.
Oh, nice.
Yeah, well, it's been raining just horrendously here on the West Coast.
Yeah, there we go.
Okay.
All right.
So
what I need, I'm going to put up a map of the moon on my computer so I can actually see. Well, there's Google Moon. Why not? Seems appropriate.
So are you... Oh, so Harold wanted to know where the chat room URL is. You're actually looking at the chat room. The fact that you commented on the thread is where this is happening. So there's no place, there's no other chat. There's only if people want to ask us any questions or comment or sort of give us some advice on what it is that we're seeing, then this is the place. So I don't know if you...
All right, this isn't working.
And earlier, unfortunately, we had Jupiter up, and we could see the bands on the planet, and I think we could even see some of the moons. But then, unfortunately, it went behind a building at Sabin's house, and so we lost it. But in theory, if we have a good observing night, or if we get a few telescopes going at the same time, we should be able to see Venus, which is up to the west right now. For most people, if early evening, that really bright star off to the west is Venus. The moon is up quite nicely right now, and Jupiter is that bright star that was really close to the moon last couple of days ago. And then if we get some really good telescopes, I mean, with Sabin, he's got a lot of atmospheric distortion. It's like in the middle of the city, and it's not definitely the best seeing. So if we can, get him out to the the dark, cold wastelands of Europe, then he would be able to have a much better view. But we could get...
That would be my parents' house. But,
we'll get him to his parents' place. Yeah, with the telescope.
I still have to source some materials and make a backpack for the toys, because it's hard to carry like this.
Okay, I've got a pretty good handle on what we're seeing here now. So for those of you watching this is a small section of the moon, and there are two obvious features here, right? There's bright land and dark land. So bright land are what are called highlands, and it's mostly craters and mountains and things like that. They're being lit. Their point of view, if you were standing there, the sun would be high overhead, so there's not much shadowing going on right now, right there. And so you don't see a lot of relief, a lot of shadowing in details. But the dark stuff, those are called mare, which means seas in Latin, like oceans. And they're dark because these were giant impact sites that punched through the crust of the moon a long time ago and liquefied a lot of the surface, or magma bubbled up and flowed out, and it's darker material. I think it's basaltic, and so these were all named after moods, basically frame of mind. And the one at the upper right, the round one, it's almost a perfect circle, although it's a little distorted because it's near the edge of the moon, is called Mare Crisium, which means Sea of Crises, and right in the upper left is Mare Tranquillitatis. My Latin is bad. I apologize. My pronunciation is probably wrong. But that's the Sea of Tranquility. That's where Apollo 11 landed. And I think, let me see, I think the Apollo 11 site is actually on there. I've got a map here, and I'm looking. Oh my gosh, yeah. If you were curious as to where Apollo 7 landed, it's not far in from the upper left corner. So if we could zoom in about 1 billion more times, we'd see footprints on the moon right there.
Right, and people always ask, like, why can't the Hubble Space Telescope see the landers on the moon? But
right, I've written an article about that. In fact,
yeah.
you point Hubble at there are two problems. One is that Hubble has a hard time pointing at the moon. The moon's moving very quickly. So you kind of point Hubble to where the moon's going to be, wait for the moon to move into the field of view, and then take a bunch of snapshots. I actually worked on some Hubble data of the moon. It was interesting. But the other problem is that even Hubble can't see anything smaller than about 150 yards across on the moon, 100 to 200 yards, something like that. So you could take in a Mile High Stadium here in Denver, plop it on the moon, and it would look like a dot to Hubble. And that's just the way it is. You know, when you see these incredibly detailed images from Hubble of galaxies and stuff, those are much bigger objects. And so that's why, you know, people say, well, we can see all this stuff through Hubble. Yeah, you can, but, you know, when you're looking at a star's a million miles across, and the Apollo lander is 4 meters across. So.
Yeah. Right now, and I know you've been playing around with the colors, right? This is full color, right, Sabin?
Yes, I dialed down the saturation because I don't have an infrared filter.
Right. I mean, for people who are kind of watching this, and it kind of looks a little, this was actually a pretty complicated challenge to do because telescopes aren't meant to broadcast into webcams and into, you know, into a Hangout. So it actually took quite a lot of technical mucking. Sabin's got an Ubuntu computer system. He hooked up a webcam to the eyepiece, and he's got to sort of pull the webcam.
Maybe black and white is better.
Yeah, I think black and white is better. And he had to pull the webcam off, you know, focus it with his eye, and then put the webcam back on. And then the other problem with most webcams is that the amount of light that's coming out of the webcam, especially when you're looking at a point object, is so bright that it sort of overexposes and it just totally washes out. And so, are you using Coriander? Was that the software you're using?
No, because Coriander is for Firewire cameras. I am using something called V4L2 UCP.
Okay.
Video for Linux 2 Universal Control Panel.
Right, and it gives you sort of really fine-grained control over the exposure settings of your camera to be able to control the exposure, and so that way to sort of crank down the brightness of the image to the point that you can actually get we can actually see the light and darkness. And with every object that he's been pointing at, he's had to change the exposure settings because, for example, Jupiter is all black except for one point that was really, really bright. But you know, earlier today, before we even started this Hangout, he was able to see, you know, we were able to see bands across the planet, and that was all pretty cool. And so, you know,
I'll take off for a minute and point the camera at another part of the moon. Is it okay?
Oh, that'd be great. Thank you. Let's see if anyone has any comments. Clay Cavaness at Google thought that was awesome. We agree. It's very cool.
Yeah,
it's
pretty slick.
Yeah, people want to know where your video is, Phil.
I'm working on it.
Yeah, we'll get. There's a couple of people that we've been working with. Sabin is one, and there's another person who's actually commented in the thread, a guy named Mike Phillips, and we've been kind of going back and forth with the two people and learning the setup. And once we have sort of our final setup, we'll try and post some how-to so people can try and follow along and join the Hangout. I mean, our dream would be that we get 6 telescopes going all at the same time, pointing at different objects. Let's have a solar telescope. Let's have a bunch at other objects at night. And if we can get them all going, and then we can just jump from telescope to telescope while people are moving them around. So, yeah, this is really exciting.
I apologize for my lack of video. My camera says it's on. Google Plus says, yeah, there it is.
Yeah, there you are. Do you remember his save?
Settings, and it's that avatar.
Yeah.
And I rebooted the camera, rebooted the software, I rebooted my computer. Oh, I haven't actually rebooted the camera. I could unplug and plug it back in. That would be interesting.
Whoa, look at those craters.
Yeah, that's pretty slick. Those are the southern highlands, it looks like. He's near Tycho. I think you can see those rays, you can see those streaks.
Wow.
That looks really familiar.
Yeah, it's hard to know because it's so zoomed in. Part of the problem as well, and I know people are watching this are kind of going, well, you know, could you zoom out? Could you zoom in? But the problem is that the amount. I'm trying to think what's the easy way to put this. So it's with a telescope. When using a telescope, you don't have a zoom on a telescope in the way that you do on a camera. You swap out different eyepieces and you have different kinds of lenses and stuff that will magnify. And so you'll see something that say one eyepiece will give you like a 30 times view, and then another one might give you like a 45 times view, and then you can use a Barlow lens which can multiply that view a certain number. So in this situation, you know, there's only so much light that can be brought into the webcam CCD sensor. So again, we don't have a lot of control on sort of how much that we're seeing. Oh, look at the top there too.
Oh, I see where we are. Yeah. That dark crater that's moving around is Plato, and that's an impact crater that was big enough to actually fill with lava and get a smooth floor. Some people call them a walled. I'm blanking on what it's called. Dang it. What he's got centered now. Oh, there we go. So you got so Plato's on the right. It's that one separate crater. That's actually a circle, but we're seeing it. It's near the north pole of the moon, so it looks elongated. That's just a perspective effect. And the big, flat, darker gray area that's dominating the view here is Mare Imbrium, which is the Sea of Rains, it's called. And that section that is like a bay at the upper left, it's like a crescent-shaped bay, is actually Sinus Iridium, which is the Bay of Rainbows. I have a map of the moon in front of me to make sure I've got these right, but you know, these are like old friends for me. I used to have my telescope at the end of the driveway, and I would look at this stuff all the time.
And so we've been having a bit of an argument with whether we should do these in black and white or do this in color. And so this is the black and white view. The color actually doesn't look as good. I got to say, I thought everyone would want to see color, but. Although it looks a little overexposed now. You had one view, Sabine, that was a little better. And also, you know, I know you were moving around the...
That's nice.
That's a good one right there, yeah.
Yep.
The other one right before
but
that.
there was when you were first slewing the telescope around, there was a really nice view where it was sort of off to the left-hand side of the moon, kind of down near the south, and there was like really good shadows across the craters that we could see, which was pretty neat.
Yes, I saw it, but I think the drift goes that way. I'm not sure.
Right. So we're drifting.
And by the way, that long stretch of darker gray just above Plato, just above the crater, that goes from the top center down to the bottom right, or to the middle of the right of the screen, is Mare Frigoris, which is the Sea of Cold, because it's near the north pole of the moon. So what else would you name it? Right? But I mean, they're not seas at all, of course. The moon is airless and has temperature swings of hundreds of degrees. There's no water sitting on the surface that way. That's interesting. You can see a shadow cast on the bay. The bay is at the upper left. It's that sort of crescent-shaped thing, and right on the horn of it on the right, you can see a shadow being cast to the left from the sun. And the crater's on the left too. You can see the shadows being cast.
So that would be like a mountain of some type.
It's probably, I mean, Mare Imbrium's the big flat region you see there. That was an enormous impact. The bay was probably a later impact that filled up as well, and it has a raised rim around it. So there are all these mountain ranges on the moon, and the moon doesn't have tectonics like the Earth does. So these mountain ranges are formed by various impacts. And so what you're probably seeing there is what's left of the rim of that crater. If you want to call it that, it's probably 150 miles, 200 miles across. And it's casting a shadow there.
That's cool. And so for anybody who's joining us, I'm Fraser Cain. I'm the publisher of Universe Today and co-host of Astronomy Cast, and we have the avatar of Phil Plait.
I'm working on that right now.
Who is attempting desperately to get his audiovisual functioning, and then Sabin Iacob, who is running his telescope from his apartment building. And what was the equipment that you're using again, Sabine? What's your telescope?
Let me look up the exact model, because
you said it was a 15 centimeter
telescope, 1000 millimeter focal length, 15 centimeter, or I guess it's 6 inches for
6
people
inches,
who
right.
don't use the metric system.
But I mean, this is not by any means a very expensive telescope. I mean, this is if you have a few $100s to spend, I mean, you can get like maybe a 4-inch telescope, 4.5-inch telescope that has this kind of a mount, although it won't have necessarily the electric, the tracking for a few $100s. With a 6-inch telescope, what is this? Maybe like a $500 or $600 telescope?
Yes, actually, if you get a Dobsonian for visual observations, it's okay. You can't take pictures. You don't have.
Right.
It's harder to do tracking, but those are a lot cheaper. This one was quite expensive.
Hey, there's some Phil.
Hey, I got it this time.
Right. So what he's saying though is that essentially there's two kinds of mounts that you can have on a telescope. There's an equatorial mount where the telescope is mounted on the tripod and it's matched to the inclination of the Earth's tilt, and what you get then is you can focus on any object in the night sky, and then the telescope will track that object as the night sky is, as the Earth is rotating, and so it looks like the sky is turning. The other and that's a kind of a fancy mount, and you can get them so that they're electric, and so the whole telescope will track at the same rate that the Earth is turning, and what that does is that keeps objects in view the whole time. The other kind of mount that you can have is what's called a Dobsonian mount, and you've probably seen them. It's like the whole telescope is just kind of sitting down on this box on the ground, and that has no tracking because you're turning left and right and up and down. But what you can do is you look through the finder scope, and then you look through the eyepiece, and you can line up the telescope on your own. And it's good for what Sabine said. That's really good for visual astronomy, so that you can kind of look through the telescope, see a really great view, and then and store it in your memory, right? You don't get to record it in any way after that. And so, but they're often very cheap. A 6-inch Dobsonian telescope, you can buy them for under $300 sometimes.
Yeah, some of them actually fit inside a suitcase. You can take them apart, and they become some kind of a suitcase.
Yeah, and I was at a star party one time, and someone had a 22-inch Dobsonian, like a home-built Dobsonian that was 22 inches. It was just unbelievable how big a telescope is possible that someone can home build. And we get emails to Universe Today all the time where people are sending us pictures or examples of the builds they've done. So
a friend of mine has a 36-inch, and he calls it his yard scope because it's a yard across.
Right.
I have one. It's a 12.5-inch, so that's 30 centimeters, and it's not a very good telescope. It's having a hard time aligning it and everything. But I can show you. Here's what a Dobsonian looks like. Right. This is clearly a homemade one. I love the yellow tube there. It's a wooden homemade mount. The tube fits on it. And the great thing about them is you say, hey, I want to go out and look at the moon, and 5 minutes later you're looking at the moon. It's that simple. And they're easy to, they come apart really easily and everything. I also have a Celestron 8-inch, so that's, let's see, 16 and 4 is 20 centimeter, and that's pretty nice. It's brand new, and I haven't fiddled with it much yet. And I'm hoping to be able to do something like this soon. because I'd love to be able to do this as well, because this is pretty stunning. He's getting really good views here, considering, this is, Sabine, this is literally sitting on a balcony in an apartment building?
Yep.
In the middle of a bright city.
Yeah, and you're facing west, so the setting sun was probably heating up that side of the building and causing the air to move around, and that's probably why we're seeing the distortion here.
Well, and every time he comes in and out of his door, opening up the door, the hot air comes out of his apartment, and you can see it kind of wash in front of the telescope, and you see the distortion. So obviously, there's about 100 things that we could do to kind of improve the process, but this is just this is just our test. We're just trying to figure out if this is even possible.
I'd love to do this here in Boulder. We have very clear skies. We have sunny days 300 days a year or more. So it's commonly clear at night, and even though we have the mountains just a few kilometers to the west of us, it's pretty steady here. So I'd love to give this a shot. But now actually the view is getting pretty good. We're seeing a lot of shadows up there. Those are all being cast by, it looks like, craters and some mountains near the north pole of the moon.
And look at that big crater there, just like a nice circular crater that blasted right into like a chunk of highlands, right?
That's Plato, named after Plato.
That's Plato. Yeah.
Actually, you know what? This view is a lot better now suddenly, because now we're seeing features in Mare Imbrium there on the left. Before it was just a sort of a big wash of gray, but now you can see there are things poking up. And, bear in mind the scale here. Let me look at my map and give an estimate. Plato, I don't know how big Plato is, but I can look that up. Plato, crater, this is all live, right?
Yes, this is live.
109 kilometers across, that's about 70 miles. Right, so for those of you in the United States, what's 70 miles across?
Like about 100 kilometers.
Yeah, the distance between Baltimore and Washington, D.C. is smaller than that, so they would both fit comfortably inside of that crater.
So in the post, Christian Reddy asked,
hey,
is there a way to enlarge the video screen? Do you mean to you can full screen the screen, and I forget how to do it, and so there's some way that you go into the code of the elements and you can make this video full screen. And as I'm saying this, I'm assuming that somebody is going to post a link to see the full screen video in the comments, and then you can see a full screen thing. Now we barely understand how to even control what's being viewed on the screen, and so I've clicked on Sabine's video, I've magnified it in my view, but we're not sure if everyone's going to see what I see on my view, or if we all see our own view. It's we're still trying to learn the the way this all works. So in a perfect world, of course, I would be able to click on different windows and then be able to show different things, different telescopes that we're talking about, as opposed to necessarily switching to Phil. So, for example, right now, I'm going to switch to Phil, and so now I see Phil as the only person up on my window.
I still see the moon, though. Oh, but I'm in the Hangout.
Yeah, you're in the Hangout, so you won't see what other people, what the watchers
now
see.
We see Phil.
Yes.
I pressed play on the public part from my laptop. So when you click on Phil, everyone sees Phil.
Oh, good. Okay. All right.
So if you click the moon, people see the moon.
Yeah. Hold on. So let me just do a search. I'll try and find the way to do this. There's a way that you can. You have to. Sorry. To Christian's question, there is a way that you can go into the settings in Chrome, and I think you have to inspect all the elements, and you can pull out the element that is the video feed, and then there's a way that you can make that full screen. I've never done it, but usually when there's like some kind of live event going on, people will do that. They'll take that, they'll post a link to the full screen video, and then everyone can click that. And so that's what I was hoping somebody's going to do. Your video looks really good, Phil.
Oh, thank you. It's a nice camera.
Yeah, it's really
but,
good.
You know, I don't think people are here to see me.
No, I'm switching back to the I'm switching back to the moon.
Well, when I'm in the Hangout window and I can move it back and forth, and when I'm looking at the limb of the moon, I do see sharp pixels. So if you made this full screen, you'd probably be over-resolving it.
Yes, because the camera's resolution is 640 by 480.
Right.
So it's not big. I guess I'll buy a better webcam and destroy it sometime in the future.
Go ahead, we'll wait. It's okay.
Yeah. I mean, again, this is just a test. This is a prototype, raw experiment, just to wonder if we even can do this. And I'm happy with the experiment so far. And then we'll take another crack at it and actually get some better gear and some better seeing and more telescopes around the world and better experts. Did that just go right past your head, Phil? All right.
No, I'm listening to you.
All right.
I heard that. I don't know if an expert can tell you that the mountains that you're seeing to the lower right of Plato, so there's like a big broad, I wish I had like a pointer I could use, but I can't. The crater on the left with the gray floor to it is sitting in a surrounding area of lighter material, and all those bumps you're seeing are mountains. Those are actually the Alps. They named all the mountains on the moon after mountains on the Earth, and those are the Montes Alpes, or whatever it is in Latin, but it's basically the Alps.
What would cause them like that?
And Apennines and
because they do look like kind of jumbled up terrain. Like
I don't know. Could be debris from an impact. That seems unlikely, though. Some of the mountain chains are caused by giant impacts and just having raised rims. Craters have raised rims, and then erosion over billions of years. Other impacts and things wear them down. This one, I don't know.
Can you kind of go back over to the left-hand side again, Sabine, so we can get those?
Yep, I was thinking about this.
Yeah.
Or take a look at Tycho maybe later too.
Where's Tycho located?
Other end of the moon. It's at the southern end. But in 2 days, Tycho will be spectacular. Right now, it's just cool. But the phase of the moon changes everything you see here. You can imagine during the day, if you have a tree, it casts a long shadow to the west in the morning. By noon, the shadow is very short, and then by the evening, the shadow is long again and pointing east. So the way you see a tree over the course of a day changes, and it's the same thing on the moon. Craters, the rim of a crater will cast a shadow when the sun is low on the horizon. When the sun is up higher, a week later, because the lunar day is 2 weeks long, sunrise to sunset's 2 weeks. So a few days later, when the sun is overhead, the shadows are much shorter, and it's actually difficult to see a lot of the terrain. So what we're looking at here, that sort of arch that you can see so clearly with the crater that's whacked it right in the middle, that's the rim wall of what's called Sinus Iridium, or the Bay of Rainbows. And it's a gigantic crater. There you go. 200 kilometers across. It's huge. And part of the rim is gone. And you can see on the right-hand side, there's part of that rim is casting a shadow. And on the left-hand side, it's in full sunlight, so it's brighter. The sun is on the horizon. If you were standing on the left-hand rim there, you'd see the sun low to the horizon. And you can tell, if you go a little bit farther to the left there, that's where the day-night line is. That's called the terminator. And you can really see a lot of terrain or a lot of relief, because craters and everything cast longer shadows, and it's much easier to see the detail there.
Well, I think
it's a gorgeous view.
Yeah, I mean, people think that they think before they use a telescope that the best time to look at the moon is when it's a full moon. But that's like the worst time to look at the moon, because you're seeing the sun is directly on the moon, and you're not seeing any of this relief, and so everything is just washed out.
Yeah, there are no shadows.
But when you get like a quarter moon, and so you've got the sunlight coming in from the side, then you get these nice big long shadows, and then all of the relief and all the mountains and all the craters are all viewed really nicely. I think, sorry Sabine, to sort of have you go back to your telescope, but this was the view that we had before. Is there another more southern view that we can see? Like a different set of
Probably.
Probably, because when you first slewed the telescope over to the left-hand side of the moon, I think you were a little down, and there was like a whole bunch of really nice craters that were in view, and then I think you moved back up. So otherwise we'll get Phil's chat again for these same features.
I'm looking for a better moon map here. Google Moon is interesting, and let me play with it again for a second. But it's not telling me what I want. Visible map of the moon. You just go to google.com/moon. Where am I? Okay, so we were just looking... Oh, that's bizarre. Where's Plato in this map? What's funny is Google Moon, the photographs they use there are with the sun shining straight down. And so it's kind of actually hard to see some of the things we were just looking at. I'm having a hard time finding them because the relief is all gone. So that's...
But yeah, so like as I was saying though, you can see over on the left-hand side of this image right now, you can see, oh, here we go.
Oh, I know right where we're looking now.
Yeah, so over on the left-hand side...
touch it down a little bit, Sabine. Oh, there you go. Yeah, he's got
a little more. Yeah, more. That's what we want. Right, so as you can see, right, over on the left-hand side of this image, you're seeing that the sunlight is casting these big long shadows across the features of the moon, but then as it's more to the right, and as we're seeing more of the direct sunlight, then we're losing the relief that really lets you get a sense of the scale and the objects that you're looking at. And you can see craters within craters within craters. One thing. So if you're watching this, if you want to reload the screen, so Matthew Toll on the comments on this thread has posted a link to the full screen player, and so you can click that link, and then you can press F11, and then that will give you a full screen view. Now, just keep in mind though, as Sabine said, this is the resolution of his camera of the CCD sensor that's actually bringing in this image is only 640 by 480. So you might be making it bigger, but you're not necessarily going to get anything. And the other thing is, if you notice, he's got this sort of two-part operation, right? He's moving the camera to the telescope to a new location, and then he's having to change the exposure settings so that depending on how much light that we're looking at, and so you can kind of see it's a...
Yeah, I actually turned on auto exposure this time, and now it's back on manual because it doesn't do a very good job generally. If it has in the Hangout, it's on in the public video, it's on the right side. In my video, it's on vice versa. It's on the left side. In my video, it's on the right. It's got a dark part, so auto exposure will just blow up everything else to light up the dark part. So.
And then you can see all those rays across the screen right now.
Those are coming from Tycho.
Yeah, yeah.
So Tycho's a fresh impact on the moon, and by fresh, it's hundreds of millions of years old. And this thing slammed into the moon and blew out gigantic plumes of material, which then collapsed onto the surface and left these long linear features that all point right toward the crater. And you can see two of them parallel, almost vertical, right through the center of the screen. And you can see a few more of them off to the right. Tycho is just below where we're looking. I actually have a map up. This is so cool. I've got a map using Google Map with a chart, and I was able to figure out where we're looking. And let's see, those if you look at the top and just to the left, there are two craters at a 45-degree angle, and they're halfway to the left-hand edge, right at the top, and the one at the bottom is or I should say the one near the top of the edge of the picture is Campanus, and the one to the lower right of it is Mercator, named after the guy who invented Mercator maps. And there's just all this amazing stuff going on. I'm just trying to look at some names of things here. Oh, my chart went away. Still playing with this, still trying to figure it out. Here we go. Is this what we're looking at?
So just to answer your question, Jay Graff asked in the comments, what would be a good telescope to get some surface detail of Jupiter? Most entry-level telescopes are going to let you see the planets and the moon. And so, you can spend $150 to $250 and get like a 70 millimeter refractor or a 4.5-inch reflector from any of the manufacturers, Celestron, Orion, Meade, whichever one chooses to sponsor this live viewing is the one we'll recommend. But yeah, and so you're looking at, like, I saw one that was just, I think it was like $250 on sale, like a Celestron 114. So there's you shouldn't spend more than between $150 and $250 and get a sort of good entry, but a good entry, so not like a really terrible department store telescope. You want like a reputable telescope from a reputable manufacturer. It's going to have good optics, a good strong mount, and that'll give you a view of Jupiter. And Jay wanted to know what will it take to be able to see Jupiter. Any telescope like that is going to show you Jupiter. You're going to see the bands across the planet. You'll see the moons. And we actually had that view earlier before we started this broadcast, and then just as we were about to start the broadcast, Jupiter went behind an apartment building at Sabin's house, so we weren't able to see it. But yeah, and so with an entry-level telescope like I just defined, you're going to be able to see Jupiter, you're going to be able to see Saturn, you're going to be able to see the craters on the moon. You'll see almost this exact view that we're looking at right now. This is a 6-inch telescope. You can get about a 4.5-inch telescope as a sort of an entry scope. You'll be able to see some of the brighter deep sky objects like Andromeda, or you can see, like, my favorite is the Ring Nebula. A lot of open clusters. You can see the double cluster, Pleiades, things like that. So there's, $150, $200 gets you started. The other recommendation that we often make is get a good pair of binoculars. There's some really amazing binoculars that are like 25 power with 100 millimeter lenses. Great big monster binoculars. They're not that expensive, and often binoculars are a great way to get into astronomy because you sort of learn the night sky and you learn where everything is, and also you will get this binocular view. Both eyes working together see a lot better than any one eye at any time, and so using binoculars for astronomy, pound for pound, is a lot more sort of a nicer experience if you can. So in many cases, when people want to, they're like, I want to get my first telescope, and we go, well, do you have a set of binoculars yet? Because that's the way to start, is get a nice set of binoculars, then move into a telescope if you're still loving it.
I agree with that 100%. I say exactly the same thing to people, and the beauty of binoculars is even if you find you don't enjoy astronomy, and what's wrong with you if that's the case, but if you find it's just too cold or whatever, everybody can use a pair of binoculars. We take them when we go hiking, we go bird spotting. They're great during the day. They're just fun to have around. So you won't regret owning a pair of binoculars, I would think.
Xavier Lumens recommended 90 millimeter cast grain for entry-level planets, or a 1.5 meter focal length.
90 millimeters, yeah.
Yeah, so like I said, so like a 70 to 90 millimeter refractor, and so a refractor is the one that uses the lenses to focus the light, or a 4.5-inch or 6-inch reflector, and the two telescopes are kinds of telescopes. They have their advantages and disadvantages, and if you want like the best visual view, you probably want to go for a Dobsonian, which has a very simple mount. But if you want to, if you think you're going to want to move into more astrophotography, then you'll want to invest more in the mount than in the actual telescope, because then you're going to get a mount that'll really nicely track the sky as you're watching.
Now, I guess one of the advantages of a Dobsonian is they're not very expensive. So, you know, you're talking $200 or $300 or $400. And if you're talking about going into astrophotography, you're going to want to be spending a lot more than that. So if you get a Dobsonian, it's not going to, you know, it's not going to put you out that much. And the beauty of them is the ease of setting them up. You know, and I know Fraser will agree with me here. There are a lot of telescopes collecting dust, even as we're sitting here, that were given as Christmas gifts or Hanukkah gifts or whatever, because they're hard to use. This is not like you're falling off a log. You have to set this thing up. You have to point it here. You have to do this. You have to do that. It's not really hard. It just takes practice, and it's got a little bit of a learning curve the first few times you do it. So the easier you can make it on yourself to get into this, the better.
Yeah.
And that's why I like a Dobsonian, because it's two pieces. It's the bottom half and the top half.
Yeah.
You haul out the bottom half, you stick the top half in it, and you're done. The disadvantages of them are that they are a little bit difficult to move. As the moon is rising and setting, you have to physically grab the telescope and move it by hand. And so you're using high power with a Dobsonian is incredibly difficult, and I wouldn't recommend it. But you're up and running in 5 minutes, and it's easy. Once you start to learn the sky and you start to figure out, you know, I want to do this better, yeah, get yourself something like a Schmidt-Cassegrain or a reflector or something. These can sit on tripod mounts, and they have the big fancy mounts on them and everything, and they're a little more expensive. But once you get them set up, they're magnificent. And wonderful to use, much easier to point at things than a Dobsonian.
Well, and you have these amazing computerized setups, right, where you just kind of, you know, telescope, show me Jupiter, and then the telescope slews over, and then there's Jupiter.
You have to spend a little while at first getting it set up. You have to point it north and do this, and point it to a star, point it to another star so it knows where it is. Yeah. But then you literally do type in Jupiter, and it. Yeah. And I remember, you know, I've been doing this a while. When these things first came out, all of the old astronomers, you know, I hate this new technology. Get off my universe. And I'm laughing. It's like, why are you guys so upset about this? You know, these people buying telescopes are missing the experience. It's like, missing the experience of what? Spending 2 hours looking for something that's, you know, that's really frustrating? Or do you want them to get out, have it point to something interesting that they can look at and say, you know, gee, this is a globular cluster 100,000 light years away, and it's filled with 1 million stars that it could all fit into the space between us and Alpha Centauri, the nearest star to the sun. You know, when you see that for yourself, it's incredible. And if it's a really frustrating, difficult process to get from being excited about something to seeing it with your own eyes, then you're losing people. So I love these computerized telescopes. I think they're fantastic.
Yeah, exactly. And that's the issue is, you know, it's that setting up, right, where you take it out and then there's like complicated software and like weird commands that you have to put into it, and you have to define, you know, you have to point it at Polaris and say, okay, I'm viewing Polaris. But they've gotten easier and easier and easier, and you can see the kinds of technology that's working in your iPhone, which has the GPS built in and knows its direction and all that, making its way into the telescope technologies as well, to eventually get this really simple. You know, plunk a telescope down and just have it track whatever you need. But the trick is that you do need to align the telescope so that the mount is tracking properly on that on the ecliptic, right? Or sorry, on the Earth's tilt.
It's a little tricky, but once you get used to it, it's an extremely gratifying experience. And you know, the first time, and I cannot stress enough, the first time you see something like Saturn. Now, Saturn's not up right now. It's up in the very early morning. But the first time you see Saturn through a telescope, you're not going to believe it. You're going to. What I used to do was set up my telescope at the end of the driveway on Halloween. And the area I live in now, we don't have any kids, but there are very few trick-or-treaters. But where I used to live in Maryland, we'd have dozens and dozens. And we used to have kids who the term is at risk, you know, low-income neighborhoods, that sort of thing. And they're at risk of dropping out of school and all that sort of thing. But they would come by And I would say, you know, you get your candy, but first you have to look through the telescope. And they'd look at Saturn, and they could not believe it. And it was always, you know, oh my God, oh that's so cool. And they would look in the telescope and see if I was faking it or holding up a book with a picture or whatever. It's like, no, that is Saturn. You know, I'd point, there it is in the sky. That's what you're seeing.
Is Saturn's up right now, isn't it, Sabine?
What do it's up in the morning?
Maybe, but it gets in my field of view at about 6 in the morning. So
okay, and Mars is up early in the morning too, I know, right?
Sabine, where are you?
Yes, I have to wait until they are close to setting, so...
Right.
Get this here. Sabine, where are you? Where are you located?
Bucharest.
Bucharest, yeah. So, I mean, that's amazing. That right there is amazing.
I know.
I'm in Colorado.
I know. I'm on Vancouver Island. How do you like your future now, huh? This is
you guys
it.
are both in foreign countries, as far as I'm concerned. So let's see. We're looking at the moon.
And so, yeah, and so, like, as I said, if people were wondering, we did have Jupiter before, if anyone's just kind of joining this, we did have Jupiter before, but unfortunately it set behind a building. So we lost it. But because it's actually fairly late for Sabine, for those of you on the East Coast, I mean, right now, if you're on the East Coast, it's like, what, 6:30 p.m. If you go outside right now, off to the west, that really bright star that you're seeing out the window, that's Venus. And then if you sort of look more off to the east and up a bit, that other really bright star is Jupiter. And Jupiter, for the last couple of days, was pretty close to the moon, and now the moon has moved a little further away from Jupiter. But yeah, so if you ever like, and all we're doing, you know, if you took a telescope and you looked at Jupiter, you would see the ball of Jupiter, you see bands across the planet, and you see the moons. And so one of the things that we can do is that we can actually know when, for example, Io is going to move right in front of Jupiter and cast a shadow across, or go behind Jupiter and sort of disappear behind its limb. And so I think we're going to try and time a future one of these so that we can have some of these events, so you can actually watch as, while we're talking, Io has its shadow has moved onto Jupiter, and as it moves across. And then the big thing that we want to do, and this is again, you know, a demonstration of what's possible, is this is the year of the Venus transit in 2012. And so come June, Venus is going to pass in front of the Sun, and it very rarely does this. It does this 2 times every 120 years or so.
108 years, 112.
Yeah, 108 years. And so it did it 8 years ago, but then it won't do it again for another 108 years. So this is kind of the last chance that anyone will be. Yeah, this will be the last chance that anyone's going to have to see this live. And so.
So I'll have to get a sun filter.
Yeah, you need a sun filter.
Yeah, you're going to need a sun filter. Yeah. Yes.
But I saw the last one in 2004, and it has to do with the way the moons. With Venus and the Earth's orbit and the way they line up, the periods of both of them going around the Sun, as well as the tilt. And because if the orbits are tilted, that changes the geometry. And so it's bizarre, but these Venus transits come in pairs 8 years apart, separated by like 110 years or something like that. It's just very strange. And I saw the last one in 2008 or 2004. I was in Washington, D.C., and the sun rose like 7 in the morning with Venus already transiting. And so I was doing a bunch of TV interviews, like local TV, and telling them, you know, oh, this happens every 100 years, blah, blah, blah. And then we had a half-hour break, and so I ran outside and actually saw this with my own eyes, and it was so cool. I had special filtered glasses, and you could, just looking without any magnification, I could see the sun's disk rising with a little black spot on it that was clearly Venus. I mean, Venus is big enough that your eye just barely resolves it as a disk, and that's only when it's really at its closest distance to the Earth. But when it's transiting, it is at its closest distance to the Earth by definition, kind of.
Yeah.
And so I could just see it as like a little disk on the sun with my eye. It was phenomenal.
Yeah.
And I can't wait to see it again. It's going to be so cool. And if we can get telescopes set up, you know, we're almost guaranteed a good view. At some place, it's not going to be cloudy. So this is flipping magic.
I know, it's exciting. Yeah, and if you ever want to, if you don't mind ruining a set of old binoculars, which I've done, is you can take the binoculars and you can take a white piece of paper and you can take your binoculars and don't look, but you can aim the binoculars at the sun, and you'll get a view of the sun sort of focused down onto this white piece of paper that you're looking at, and you can actually see sunspots on the sun, and in this case you would actually see Venus or Mercury, moving in front of there's some kind of transit. The only thing you want to make sure is you don't do it for very long, because you can actually kind of cook and melt the optics inside the binoculars, and I've done that too. I've left it staring at the sun for too long. But whatever you do, don't look through the eyepiece. You want to project it through. But it's pretty neat because especially when you're getting like when a partial solar eclipse, things like that, you can just view it wherever
Actually,
you are.
I'm checking my map here.
People are saying that Mars and Saturn are up.
Mars is up where Sabin is, but I believe it's on the other side of his building.
Yes.
So you can't see that. And I love this. I've got software where I typed in Bucharest, and it said, okay, here's the sky over Bucharest right now. Fantastic. So, I can see where the moon is, Jupiter's setting. Orion is not far from where we're looking. I don't know.
Yes, it will
Might be tough with the moon being so bright.
Actually, it should be visible, or maybe right behind one of the buildings on the left side of the street here.
And the other thing that's so much fun here is I'm looking at a map of the moon. And so I know where we're looking right now. And if you look at the top of the screen, a third of the way from the left is a big round crater with a dot in the center. That's Arzacle, or Arzachel. I don't know how that's pronounced, but that's a nice impact crater. It's just 100 kilometers across, so 60 miles, right? That's the size of a U.S. state, a small one, but still. And then just to the lower left of it are a pair of craters, a big featureless one with a nice little one on its rim at about 11 o'clock, and the big one is Thebit or Thebit. Or, I don't know how to pronounce that, the bit, that's how it's spelled. And I don't actually see a name for the crater on its rim. But it's amazing. I mean, I'm just looking this stuff up as we're viewing, and you can see what it is we're looking at. I want to see what these two. It's hard. The map is very detailed, and it makes it difficult. But it's fascinating. This is real-time astronomy. If an asteroid a mile wide were to hit the moon right now, we'd see it. That won't happen. So, but there are impacts on the moon. There have been flashes of light seen on the moon that have corresponded to meteor showers, like last night's quadrantids, if anybody saw those. And they've been independently confirmed. Something smacked into the moon, probably something small, this big, size of a grapefruit or a basketball or something like that. Those would burn up in our atmosphere and create a really bright fireball. But on the moon, there's no atmosphere, so boom, they hit the ground. Flash of light, it lasts for a fraction of a second. But they've been seen.
If we can get a favor for people to know sort of how many people have actually discovered this, two things. If you're enjoying this, if you could share it. And then the other thing is that if you could +1 it, so we can kind of just get a sense of what's the total number of people who are viewing this, because we actually have no way to know what's going on.
Yeah, there are 33 +1s, 21 shares, and over 100 comments. Oh, hey, Fred Bremer. Fred Bremer's in your neck of the woods. He's from Victoria.
Yeah, I know. He's from Vancouver.
Or Vancouver, sorry.
Yeah,
one of those
Fred.
things.
Where I don't see the Fred. Are we looking at two different? You know what? I think there's two different threads.
I'm in your Hangout right now, and I see 100 comments. I shared it.
Right, I see 103 comments, 51 pluses, and 28 shares. Is that right?
And then it says, people I've circled, and it says, who's +1'd it. It says you, Fred Bremer, and 31 more.
Right. Okay. So Fred's watching. Cool.
Yeah,
Fred runs the Skeptics in the Pub.
This is neat. Is there a way to let me or anybody interact with Sabin's feed? That would be the most awesome thing ever in the whole universe, because then I could just point out this crater here is this, or look at this feature here. But
yeah.
unfortunately, there's no way to do it.
Could, if you brought his feed-ins through some other method, some other window, and then you screen shared it, and then you could switch to that screen.
I can't screen share this.
Well, maybe only I can. So
yeah,
because
that
I'm
was
the host
today on that Google Plus Hangout where we were on earlier. That was being done by the Google people. There was a screen share option in my Hangout window, but that's
I have a screen share option. I can screen share stuff.
Well, then you could go to Google Moon and do that.
I had Hangouts with extras for a while, and now I don't see it anymore. But maybe it's because I'm on Chrome now. I think I saw it in... No, actually no, it was available.
Yeah, there are quite a few features here that Google Plus has allowed, and there's a lot more they can still do. In a few months, this is going to be really amazing technology because it's only okay right now. You might notice too in the moon feed, there's a dark spot just